Good morning, chemistry students. Here are the last little bit of your Chapter 8 notes. So this is day 6. We're going to start at that ionic equation and we're going to finish out the chapter. And we're going to start with a little review. So we did this just the other day, where we took this aqueous silver nitrate reacts with aqueous sodium chloride. And again, remember the first thing that we did was we made it a word equation. So it was silver nitrate, and we put kind of our states of matter in it as well so that we would know. And sodium chloride, okay. And then again, this was a double replacement reaction. So silver's a metal and sodium's a metal, so they're going to swap partners. So silver's partner is going to be chloride. And I told you the other day, today you're going to learn how to do this, but I told you the other day it was a solid. And sodium's partner is going to be then nitrate, which I told you was aqueous. So that was our word equation. Next step is we take our word equation to a skeleton equation. So again, we're going to make everything symbols. Silver is Ag. It has a charge of +1. Nitrate's NO3, charge of -1. Nothing to do to that one. Because we're working towards a complete and then a net ionic equation, we have to include our states of matter. So then we have sodium, which is Na, charge is +1, chloride is Cl, charge is -1, nothing to do, and it's aqueous. Silver is Ag, +1, chloride Cl, -1, nothing to do, but it's a solid. And sodium is Na, charge is +1, nitrate is NO3, charge is -1, nothing to do for crisscrossing, so we just do our states of matter. So that was our balanced chemical equation, and when we balance this, we just have ones of everything, so we don't have to worry about any coefficients. This is a skeleton equation that was a balanced equation. So next we did our complete ionic equation. And in our complete ionic equation, remember, we take everything that is the aqueous state of matter and we break it up into its ions. And when we write that, our ions have to have a symbol, they have to have a charge, and they have to have a state of matter. So we have Ag plus aqueous plus our nitrate, NO3, negative aqueous, plus our sodium ion, aqueous, plus our chloride, aqueous. Now, we don't break apart the silver chloride because it's a solid. And if we're going to rewrite a compound formula, we should leave the charges out. And then we're going to break apart the sodium nitrate, so sodium ion and nitrate ion. And then, again, our next step was to identify our spectator ions. We know who the spectator ions because they appear in exactly the same way. So they have the same symbol, they have the same charge, they have the same state of matter on both sides of the arrow. And again, remember that was sodium ion and that was nitrate ion. So we had identified those the other day at the end of our notes as our spectator ions. All right, so that's kind of a review of where we were at, and we're going to need this equation, so that was part of the reason for the review. So let's talk about then, now how do we take our complete ionic equation and the spectator ions that we've identified and write a net ionic equation? So the definition of a net ionic equation is an equation Okay, so a net ionic equation is an equation that indicates or shows only those particles that actually take part in the reaction. So again, it's kind of a little bit like our word equation. It's allowing us to focus on what's important. Here it's allowing us to focus on what's important in these double replacement reactions that are taking place in aqueous solution. And to get our net ionic equation, we are going to cross out or leave out the spectator ions. So again, remember, those are those ions that are exactly the same on both sides. They're really not participating in the chemical reaction. So we're going to actually just leave them out. One of our check steps is that we have to make sure that our overall charge of our equation must balance. So if we take that same example that we were doing, right, and we had the silver ion plus plus the nitrate ion plus the sodium ion. This is that one that's just on the previous slide that we just reviewed. And that produced our silver chloride, which we didn't break apart because it was a solid. But we had our sodium ion and our nitrate ion. And we said that our spectators were the sodium ion, the nitrate ion and the sodium ion. So to write our complete or our net ionic equation, what we do is we take that complete ionic equation that we've written and we rewrite it, but we leave out the spectator ions. So we end up with Ag plus aqueous plus Cl minus aqueous yields AgCl solid. And pretty much in this reaction, that's all that's happening. Okay, I have silver nitrate dissolved in water. I have sodium chloride dissolved in water. When I drop or react them together, the silver ions go and find the chloride ions and they form a precipitate. They form a solid. So this is our net ionic equation. Now, I will tell you that there is a pattern. And when you see the pattern, you don't necessarily need to write the complete ionic equation every time. Unless it asks for complete ionic equation, I don't need one. But until you see the pattern on your own, you should write out the complete ionic equation before you write the net ionic equation. So the other day when we did this, I told you that silver chloride was a solid. But now I want to show you how you're going to figure that out for yourself. So we're going to talk about predicting the formation of a precipitate. And again, we're going to specifically define precipitate here. A precipitate is an insoluble salt. Insoluble means it can't be dissolved in water. Salt is just a way of talking about an ionic compound that's made of a cation and an anion. It doesn't mean like table salt. Okay? And precipitates result from mixing two ionic compounds. So this happens because we have mixed ionic compounds. So we have some rules to follow. They're called the rules for solubility, and they're on page 227 in your textbook. They're table 8.3. This is what those rules of solubility look like on your outline. Now, this is not something you have to memorize. This is now you're going to be added to your helper sheet, okay? But this is what it looks like on your outline. So let's work through this. So it says salts of the alkali metals. That space is so that you can remind yourself who the alkali metals are. The alkali metals, okay, are group 1A. And ammonia, okay, ammonia is ammonium, your ammonium ion, so that's NH4 plus. Now, when you look at page 227, you'll see that in solubility it says soluble. And down here at the bottom it tells you soluble means it can be dissolved in water. What that means, and what I would suggest, is that you put like a little note that means you should put aqueous as its state of matter. Now, exceptions, it says some lithium. That's so that you can write the formula for lithium there, which is Li, okay, plus compounds. So what that means is if you have a lithium compound, like a lithium compound of some sort, likelihood is you're going to put that it's a solid because it's an exception to being soluble. So rule number 2 says nitrate salts. Remember, nitrate you have memorized as NO3, the charge of -1. And chlorate salts, which you also have memorized as ClO3 with a charge of -1. Nitrate and chlorite salts, according to your chart, are soluble. Again, what that means is, and what I would put on here, is that it's aqueous. So that means it's going to be in the aqueous state of matter. And notice that there are few exceptions to this. Rule number 3 is sulfate salts. Remember, sulfate is SO4 with a -2 charge. So salt means you're looking for a compound that has sulfate in it. Okay? And sulfate salts are also soluble, which means you're going to put aqueous for their state of matter. Now notice there are some important exceptions here. If it's a lead sulfate, a silver sulfate, a mercury sulfate, a barium sulfate, a strontium sulfate, or a calcium sulfate, they are an exception to being soluble, which means they are a solid. Rule number 4, chloride and iodide salts. Chloride is Cl, -1. Iodide is I, -1. And for solubility, they are soluble. Again, that means they're going to be in the aqueous state of matter. Now notice, again, we have some exceptions. So if it's a silver chloride or a silver iodide, okay, it's going to be insoluble. It's an exception to being soluble. And many lead chloride and lead iodide and mercury chloride and mercury iodide compounds also are going to be an exception to being soluble, so they would be a solid. Rule number 5, we have the carbonates. The carbonates are CO3, the charge of -2. Phosphate is PO4 with a charge of -3. Chromates are CrO4 with a charge of -2. And sulfide is S with a charge of -2. And hydroxide is OH with a charge of -1. Right, all but sulfide there, those are polyatomic ions you're supposed to have memorized. So carbonates, phosphates, chromates, sulfides, and hydroxides, Okay. Most are insoluble. So what does that mean you should put for its state of matter? If they're insoluble, that means that they're going to be a solid. Now, notice exceptions, compounds of the alkali metals. Again, remember that's group 1A. Okay. And of ammonia, which is NH4+. Now, they're an exception to being insoluble, which means they are aqueous. So, that's the chart. Now, we're going to use this chart to do an example. If you need more time to fill this in, remember you can pause your video. So again, for our example, we're going to go through all of our steps. We're going to take our sentence to a word equation, to a balanced chemical equation, to a complete ionic equation, to a net ionic equation. So again, we're going to go through all of those steps. So our reaction is silver nitrate reacts with potassium sulfate. Again, I haven't given you the products because you should be able to figure out what the products are. Remember to identify the products. We need to identify what kind of reaction this is. So if I start my word equation, I have silver nitrate reacts with is my plus, potassium sulfate. Now, what kind of reaction is this? I have two reactants. They're both compounds, so guess what? This is a double replacement reaction. So that means the positively charged ion swap partner, silver and potassium are my metals, so they're positively charged. So silver's partner is going to be sulfate, and potassium's partner is going to be nitrate. Now, this is a good time for us to go and take a look at our states of matter. So, we go back to this chart, and for the first one, we're looking for nitrates. So, that's rule number 2. Nitrates are soluble with few exceptions. So, that means silver nitrate's going to be aqueous. All right, our next one is potassium sulfate. So we're going to look at rule number 3 about sulfate salts. And it says they are soluble. And potassium is not listed as one of the exceptions. So for potassium sulfate, I'm going to put aqueous. Next, I have silver sulfate. So I'm going to look at that same rule, rule number 3, sulfate, soluble. But notice silver is listed as one of the exceptions. What that means is for silver sulfate, I'm going to put a solid. So I've identified my precipitate, but I should finish checking. So my last compound is nitrate. So again, I'm going to come back and look at my rule. That's rule number 2. And nitrates are soluble with few exceptions. So that's going to be aqueous. All right, next step. To take this, word equation and make it a skeleton equation. So everything is in symbols. And remember, I want to leave room in front of my compounds for coefficients. So silver is Ag. Charge on my helper sheet is +1. Nitrates NO3. Charge is -1. Nothing to do with crisscrossing. So there's my silver nitrate. Potassium is K. Its charge is +1. Sulfate is SO4. Charge is -2. So I need to make this K2SO4. And it's aqueous. Silver is Ag. It's still a charge of +1. Sulfate's SO4. Charge of -2. So I'm going to write this as Ag2SO4. And it's my solid. Potassium is K, charge of +1, nitrate NO3, charge of -1, nothing to do in terms of crisscrossing. I put my states of matter. Now I want to balance it. So I have 1 silver, 2 silvers. I need a coefficient of 2 in front of silver nitrate. I have 2 nitrates now. I have 1 nitrate. I need a coefficient of 2 in front of silver nitrate. I have 2 potassiums. I have 2 potassiums. I have 1 sulfate. I have 1 sulfate. So this is now correctly balanced. So now that I have balanced it, now I'm ready to do my complete ionic equation. Remember my complete ionic equation, anything that is the aqueous state of matter is going to get broken up into its ions. Now notice we have some coefficients this time that we didn't have when we did this before. What that means, remember, our coefficients mean is that there's 2 silver nitrates, which means when I break this up into ions, I'm going to have 2 silver ions and 2 nitrate ions. So these coefficients are going to stay coefficients. So as I write my complete ionic equation, I have 2 Ag plus aqueous plus my 2 still, because there's still 2 nitrate ions, aqueous. Now, this subscript here still means there's 2 potassium ions. So I have 2 K plus aqueous plus just 1 sulfate ion, aqueous. I don't break up my silver sulfate, so that's going to be Ag2SO4 solid. But I do break up my potassium nitrate, and I have that coefficient of 2 in front of it, so I'm going to have 2 potassium ions and 2 nitrate ions. So now that I have written my complete ionic equation, now I want to identify who my spectator ions are. Okay, so again, who exists in exactly the same way on both sides? Here's my silver, it's aqueous. Over here it's a solid, so it's not. Here's nitrate, it's aqueous over here, so it's a spectator ion. Here's potassium ion, here's potassium ion, it's a spectator ion. So again, if I'm asked to identify my spectators, remember you have 2 choices. I could say NO3, -1, and K plus, or, okay, you can do their names. I can say nitrate and potassium ion. I have to have the word ion after potassium so that I know it's an ion. All right, so now we've done our spectators. So now we are ready to write our net ionic equation for this one. So our net ionic equation is 2Ag plus aqueous plus SO4 -2 aqueous yields Ag2SO4 solid. And remember, we figured out what the precipitate was using our solubility rules. Now, remember, our kind of check step on this back here was that overall the charge must balance. Oops, sorry. +2, -2 equals 0. And over here, we don't have an overall charge, so it's 0. So our overall charge does indeed balance. So that's an example where you have some coefficients, and you have to use those. And also where we used our solubility rules. Remember, you don't have to memorize the solubility rules. They're now going to be added to your helper sheet. So your homework is on page 228, 28 through 31. Again, do not type this. Okay? I want you to handwrite it out. Takes way too much time, and when you type, superscripts have to be superscripts and subscripts have to be subscripts. It's a pain in the butt to do when you're typing. Handwrite it out and take a picture of your homework to turn in. Have a great day. I'll talk to you tomorrow.